our dear candidates. I welcome you to lesson 20 about the circumference. I know the other time you talked about circumference of circles, but today we are going to look at how to apply the knowledge you got, and then we continue finding the circumference and knowing how circular objects can be operated with the idea of circumference. Therefore, we shall look at how to apply the idea of circumference to know how circular objects do move, or how we can operate them with the idea of the distance round the circle. So with that, we are still looking at more about circumference of a circle, which brings us to the idea of revolution. In the different subjects, we always talk about revolution, and then we talk about the turns. So a revolution is a complete turn. A revolution is a complete turn, which means you must make a complete turn of 360 degrees. A complete turn means 360 degrees. I want you to take a look at what I'm having in my hand. This card is what we call a circular card. It has got marks. You are seeing some words there. When I put at the center, the letter you are seeing there is letter W. So when we say a revolution is a complete turn at a total angle of 360 degrees, and I make a turn from here, my letter W is facing the center. When I make a complete turn, I should come back up to that point. So let's move. Look at this. This is what we call a complete turn. A complete turn is always a combination of the circumference. When I rotate this thing once from this point, coming back here, like this, means it is my circumference. The distance moved in one revolution or one complete turn is the same as the circumference of the circle or the circular object. We can have a flat surface. You can have a flat surface like this one here, and then I put my point. You're looking at that. It is letter W there. I must roll this until I come back to that point, until it touches or it comes back to the point where you are seeing letter W. So I will roll this, I'll roll this, I'll roll this until you see my letter W back. Aha! This one means the distance I've covered here, the distance is the same as the circumference of these circular objects. Let us come back from this point. Let's come back until I reach my letter W, until I reach it from here. Aha! This one means the distance covered in one complete revolution is the same as the circumference of the circular object, the circular card I'm holding here. So our turn should always be a complete of 360 degrees. We shall continue from there to relate a revolution together with the circumference. But before that, the revolution goes hand in hand with the numbers. The number of times the wheel rolls, or the number of times it turns, is what we call the number of revolutions. So there, when you look at that point, they're saying the number of revolutions is the number of times a wheel or a circular object turns to complete a given distance. And the distance we are talking about here, the distance covered in one revolution, according to what we are showing there, is equals to the circumference of the circular object. The distance covered in one revolution is equals to the circumference of the circular object. Let's take a look at this. And we are saying, since the distance covered in one revolution is equals to the circumference. How do we get the number of revolutions? We shall say our number of revolutions is equals to the distance covered. Because the distance covered has multiple number of revolutions, divided by the circumference. For us to get the number of times the wheel turned to complete a particular distance, we have to get the distance covered divided by the circumference of the wheel. Let's look at our first example. The question is saying the circumference of a bicycle wheel is 88 centimeters. How many revolutions can the wheel make to cover a distance of 352 meters? Read the question very well and look at the units. When you look at our unit here, it's reading in centimeters. And then here, the distance is in meters, so they don't rhyme. You have to make them the same. How do we make them the same? We can choose one of the units and then we convert all these two to appear as one unit. So which one is easier for us, learners? We can change all of them to centimeters. So which one are we going to change now? It is the distance. We are going to change the distance from meters to centimeters. How do we go by that? We are still demonstrating here. What the question is talking about there is what has been shown here. This is our circular object. With the total distance, the distance round as 88 centimeters. And the distance covered by this object is 352 meters. So let's change the units by saying our 1 meter in primary 4, 5 and 6 we talked about this. And I want us to summarize in the easy way by saying 1 meter is equals to 100 centimeters. So how many meters do we have here? 352 meters. We are changing from a smaller unit to a bigger unit. Sorry, from a bigger unit to a smaller unit, which means our value will go higher a bit. So what do we do there? We multiply. So if 1 meter equals 100 centimeters, how about 352 meters? Will give us 352 times 100, and the unit should be in centimeters. Let us simplify and get the answer. So 352 meters is equals to 35,200 centimeters. We are now free to get the number of times the bicycle wheel turned to cover the distance of 352 meters. So let's look at that by saying the number of revolutions, in simple terms we have used that, equals to the distance covered divided by the circumference. Do we have the circumference of the wheel? Yes, it is 88 centimeters. So we shall come and substitute. In simple terms, R stands for the revolution or the number of revolutions, and then the D is for the distance, then C for circumference. So let's move on. After substitution, our R is the revolution, then 35,200 centimeters is the distance covered by the wheel of circumference, 88 centimeters. Let's look for the common factors between 88 and then 35,200 by simplifying. How do we do that? We have to divide. Therefore, let's have this. When you divide 88 by itself, we shall get our answer here as it. Sorry, we are going by 11, we shall get here 8. Then when we divide the other side by 11, what is our answer? We shall get 3,200. The same numbers, we keep moving. To make our work simple, we have to shift the number so that we remain with it. 3,200 divided by 8. Therefore, when you divide this one by 8, 8 by 8, what are we going to get? Get 1. Then we go 3,200 by 8, shall get a total of 400. So how many times did the bicycle wheel roll? Or how many times did the bicycle wheel turn to give you 352 meters? It turned 400 times. So we call it 400 revolutions. You go through your work. Make sure at home you have very many circular objects. You can try to demonstrate the way we have been doing here. You have bicycles at home. Some of you have cars. Some of you have wheelbarrows for carrying the rubbish. So you can try to roll it. Set a point. Then you say, I'm going to roll from this point to the next. You can tie something at a particular one point, and then you move. You see how many times you roll when that point is touching the ground to cover the particular distance. Let's look at the next example. After underlining our answer, you can look at the next one. Saying, how many revolutions can a wheel of diameter 17.5 centimeters make to cover 4.4 kilometers? Remember, in number 1, or in our example 1, we had centimeters and meters. This time, they have given you the diameter. The other time, they gave you the circumference directly. So what do you need here? You need to make this number here given to you as the diameter. The diameter is the distance passing through the center from the edge of the circle. So if our diameter is given, which means before you go to any other thing, you should know the distance around the circle. So we need to find what we call the circumference of the wheel, the circular object. So how do we go by that? We shall have our circumference, when you're talking about it last time, is pi d. We looked at how to find pi. We calculated how to get pi from the distance, from the circumference, and then from the diameter. So if our circumference is pi d, then we shall have our circumference. Our pi is taken as 22 out of 7 times the diameter, which is 17.5 centimeters. Let's change 17.5 from mixed fraction to an improper fraction, which gives us this. We have 22 out of 7 times 35 out of 2. 17.5 is the same as 35 out of 2. We multiply 2 times 17 plus 1 out of 2. Let's look at if we have common factors between 22, 7, 35, and 2. So how do we go by that? We shall have our 7 divided by 7, we shall get there 1. Then 35 divided by 7, we shall get our 5. Shall go to 2 divided by 2, we shall get 1. Then 22 divided by 2, we shall get our 11. Therefore, our circumference will remain as 11 times 5, which gives us 55 centimeters. Because this is 1 times 1, it remains 1. So we have 11 times 5 giving us 55 centimeters. We now know the distance round the circle or the width which we have there, given the diameter. So if the circumference is 55 centimeters and the distance to be covered is 4.4 kilometers, we still have a task to change these units to be the same. Look at here, it's in kilometers, and this one in centimeters. So we need to change from kilometers to centimeters. How do we get that? In 1 kilometer, for you to cover 1 kilometer, is the same as 100,000 centimeters. How many kilometers do we have here? We have 4.4 kilometers. So we have to say 4.4 kilometers. In simple terms, 4.4 is the same as 44 out of 10. We multiply by the number of centimeters in 1 kilometer, giving us a total of 440,000 centimeters. We have a total of 440,000 centimeters. We now have similar units, here centimeters, like here. We are now free to find the number of revolutions by saying the number of revolutions is the same as the distance divided by the circumference. Can we substitute? Our distance is 440,000 centimeters and the circumference is 55 centimeters. Can we get the common factors? What are the common factors there? 55 divided by 11, we shall get 5. 440,000 divided by 11, we shall get 4,000. What about 5? We shall get 40,000, not 4,000. When we divide 5 here, we have now 40,000 out of 5. To make it simple, You get this number, express it out of this, and then we have this. So 40,000 divided by 5. We shall begin by 5 here, we shall get our 1. Then 40,000 divided by 5, our answer is 8,000. So how many times did the wheel turn to cover a distance of 4.4 kilometers? The number of times is the same as the number of revolutions, giving us 8,000 revolutions, or 8,000 turns. The number of times it moves is called either the turns or the number of revolutions. Let's take a look at the next example, giving us the distance from town A to B can be covered by a wheel of diameter 35 meters in 100 turns. Let's take a look at this. There is some bit of a problem. Our in is supposed to be with the IN, not with INN. So you ignore that and then you write it properly. It's IN. In 100 turns, find the distance between the two towns. This one takes us back to our example 1 and 2. They were talking about the number of turns. But our example 3 is now talking about the distance covered. We need to go back and review our work. We are talking about the number of revolutions, and we say to find the number of revolutions, you divide the distance covered by the circumference. Because the distance covered by the circular object in one revolution is the circumference of the circle. So this one is saying the distance from town A to B can be covered by a wheel of diameter 35 meters in 100 turns, or in 100 revolutions. Find the distance between the two towns. Let's take a look at what we are supposed to do. This one is asking for the distance. So the first thing to do is to know the circumference of the wheel, because they have given you the diameter. It is not new. In example 2, we talked about it. So we shall have our circumference as pi d. Substitute, our pi is 22 out of 7 times the diameter, which is 35 meters. What do we get from there? We divide this one by 7, we are going to get 1. Then 35 divided by 7, we shall get our 5. So what is going to be the circumference? Our circumference will be 22. We are going to multiply by 5 meters, giving us a total of 110 meters. Every time they have given you the diameter, you should know that that's not the distance round. You must know the circumference to make you find either the distance or the number of turns. So we are now free to find the distance covered. It is different from the formula we used there, but we can use that formula to convert. But now we are going to move straight and say the distance covered has changed the order, equals to the number of times the wheel turned times the circumference of the wheel. So we shall have our point there. So we shall have the distance d is equal to the number of turns, 100 turns, times the circumference we got here, 110 meters. Sometimes they will tell you to find the distance in another unit, but this one is quiet, meaning that your distance is supposed to be in meters. So let's multiply 100 times 110. I'm not going to carry out the vertical multiplication because these are multiples of 10 where there are zeros. It makes your work easier. So we shall have here our distance covered as 11,000 meters. The distance covered is 11,000 meters. If the question was demanding you to change the distance in kilometers, there you would continue. But still, we can move on and express it. So you can easily change 11,000 meters to kilometers by saying 1,000 meters is equal to 1 kilometer. So how about 11,000 meters? It is the same as 11,000 divided by 1,000 times 1 kilometer. What do we get from there? We first simplify. By 1,000 here we shall get our 1, and the other side by 1,000 we shall remain with 11. So our distance in terms of kilometers is equal to 11 kilometers. Though the question here has not demanded, but in another question they can ask you to find the distance in kilometers. It can be in centimeters, but they can still ask you to find, because our common distance we always need to find them in kilometers meters, decimeters, and any other unit. Can have it. Thank you very much for following through the lesson. I still remain your teacher, Obonyo Alex. Thank you very much. Make sure you wait for the activity. God bless you.